Let's talk about the data pipeline. Here's the objectives slide. Please pause and read it before proceeding. Before I begin talking about the data pipeline, one thing I want you to know is that what really surprised me as I was developing this course is I could not find any of this material I am about to show you in any textbook. All of the material that you'll learn in this video is material that I've had to accumulate over years of experience in working with IT teams. As a data professional, you must make IT staff your best friends. In any company, how well your IT staff support you can make or break your data analyses. You must work well with your IT folks, and you must learn IT terminology. IT, or data warehousing teams, are traditionally the people that help to build the infrastructure so that you, as a data professional, have data you can gather for analysis. If that infrastructure doesn't exist, you won't have any data. In every company I've worked for as a data professional, the first thing I always try to figure out is how to get access to the data. You will not get access to any data if you don't have an IT professional managing it already. I cannot overstate the importance of working well with IT folks as a data professional. Please keep this in mind as we go through this lecture. So, what is the data pipeline? The data pipeline is simply how data flows from its source content to being used. The data pipeline could be most easily summarized in three phases: source data, staging data, and output. Source data is data in its rawest form in varying degrees of cleanliness, usually as either an Excel file, a text file, or perhaps most ideal, a table from a database. Staging data is the cleaned out form of source data. Staging data is data that is cleansed and in the form that you need so you can use it for output. Output is the final product from the use of data. It could be a report, or it could be a predicted value from a statistical model or machine learning algorithm. DSci 2000 primarily focuses on taking source data and turning it into staging data. This is actually the majority of the day-to-day work as a data professional. Most academic programs tend to focus more on staging data and turning it into output. That is, the focus tends to be on taking data that's already clean and turning it into a product. This makes sense if you're trying to learn statistical and machine learning techniques, but as I mentioned in a previous lecture, most organizations are not at the point where they're ready for these things. Here's what an ideal data pipeline looks like. In an ideal world, you'd have stakeholders or related staff do all of the data collection, have an IT, data engineering, or data warehousing team manage the infrastructure, and then the data professional comes in to turn the data into staging data and make an output out of the data. While in a theoretical sense, this is what the data pipeline would look like, in a practical sense, this is unrealistic. In fact, no company I've ever worked for has ever worked this way. I'll elaborate on this in a bit. Let's define these terms. A stakeholder is just someone or some set of people who have collected data for the express purpose of being used. ETL, or extract, transform, load, is traditionally IT terminology, and I haven't seen this mentioned in any data science textbooks, but it is a fundamental part of data in practice. Broadly speaking, ETL refers to the process of taking extracts of raw data and transforming them so that they are ready to be loaded into something like a database of tables. We're not going to cover all of the nuances of ETL in this class, but you need to at least be aware of what it is. ETL, in an ideal world, is performed by teams such as IT teams, data engineering teams, or data warehousing teams. If you ever hear anyone talk about data warehousing or data engineering, that's basically ETL. In an ETL environment, one usually separates ETL into three environments: development, testing, and production, abbreviated as dev, test, and prod. Dev is where you develop your database, test is where you test your database, and prod is the database that is for general usage for people like data scientists. Sometimes there is an acceptance stage after test, and some people refer to this four-step process of dev, test, acceptance, and prod as DTAP. So we've talked so far how in an ideal data pipeline, the stakeholder collects data, A data warehousing team handles ETL and puts data into prod, and then an analyst will pull from prod, clean up the data for staging, and then get an output at the end. As I've mentioned, while it may make sense theoretically, I've never seen this actually happen in practice. It happens more often than you might think, but I've had to be involved in ETL processes and testing of databases as an analyst. Organizations are varied in how much they're going to invest into using data, and as you might be able to see, the ideal scenario requires a lot of staff. Thus, the data pipeline will often look different as you go from organization to organization. Parts of the data pipeline may not even be built. Another thing that is worth mentioning is that it is possible to go backward in the data pipeline. An example is the following scenario. You've run some numbers for output, but the requirements of your project have changed. You might have to collect new data in this situation, or go back to a production database and pull additional data. Enough about the ideal scenario. Let's talk about actual examples of the data pipeline I've seen in practice. This first example was one where some IT infrastructure had existed, so I could pull from their production level database, but I was also responsible for doing some of the data collection. At times, I would have to combine the production level data and the data I collected myself in reports. One might wonder why IT doesn't just manage the collection as well as take the data through ETL. One of the things you'll learn about if you work professionally is that it's often not possible that all data of interest can flow that easily. Some companies which have data that may be of value to you as a data professional may make it either very difficult or impossible to pull their data in an automated fashion, so you might have to do it yourself manually through a point-and-click interface. Another thing is that IT teams may not have the time to learn a new data source, or the expertise to perform ETL on it properly. Every data source, as you will learn in this class, presents its own challenges. Here's another example of a data pipeline that I've seen in my professional work. This is an example of a pipeline where there has been absolutely no established infrastructure, and you have to manage the collection, perform ETL on it, get it into a database, and do reporting on said data. Many people who don't have the technical background to understand how to work with data unfortunately think that this is how a data pipeline should be managed. One so-called data person manages the data. It places a lot of pressure on one person, as that person is trying to wear many hats at once. Here's another example of a data pipeline. In roles where I've had to do a lot of reporting, this pipeline has been the closest to ideal that I've seen. Both the data professional and stakeholder are responsible for data collection. There is also an IT team maintaining some ETL and a production level database, and the analyst is responsible for taking this data together and reporting on it. So this is really to say, in a data job, you should not expect to only be handed clean data. Depending on the organization, you may have to wear many hats. I'll end by talking about where DSci 2000 fits in with the data pipeline. You'll essentially be assuming what I've seen to be the ideal scenario in practice, working with some Excel or text files, working with data from a production level SQL database, cleaning up data for the staging phase, and coming up with an output such as a report. If you want to dig more into some of the other aspects such as data engineering, you'll need to take a class that focuses on infrastructure, which can take many different forms. I won't have time to go into much depth into this, but it's worth mentioning that developing cloud infrastructure for data is a hot topic right now. As usual, please let me know if you have any questions.